The marching Purdue Pete. It's done by me, Omar, John, Jack, and Usma.
So our idea behind this toy was to kind of make something that kids would like to play with, and also that like Purdue alumni and fans would also like to collect. It's to celebrate, of course, the 150th anniversary of Purdue University. And the toy is designed as Purdue Pete's with a snare drum marching and playing.
These are like the pictures of the final model. We're going to show you a demo pretty soon.
So for the key features, it's pretty much completely mechanical with the exception of the motor, obviously. So no springs or anything, no winding, but everything that's not the motor spinning is a mechanical linkage. So that kept us from having to use any kind of Raspberry Pi or Arduino and any programming. So it simplifies the use of the toy, even though the mechanical part of it got a little bit more complicated as a result. It consists of the one motor, like I said, and we've been using a resistor to play with the speed of the motor. We're still working on that, trying to find the perfect speed. Our initial thought was to have this actually be like a walking toy, and we wanted to move forward, but balance has been a pretty big issue with that. So either we're looking at redesigning, or when we came up with this idea, our first thought was to actually have it just be like a marching Purdue Pete, like in place. So maybe being able to add like stationary supports that allow it to still do the motion and like march in place instead of trying to actually move forward, since the actual walking on two legs is a little bit iffy, even though we did add a third support. So it consists of one cam wheel and 4 link bars per side. So basically what happens is the cam rotates and it drives this whole linkage assembly that actuates the legs and the arms. So we have 7 pin joints, and our degree of freedom is 1 for the linkage. So we'll give a demo here very shortly on that.
Yeah, so comparing between commercial production and a prototype, definitely commercial production is going to have more real looking hands and feet. Our prototype simply because of constraints on time, we tried to use straight thin links, and we just wanted to make sure that the prototype works. Other than that, we had to redesign before 3D printing. We had to separate the body and the drum. Our initial plan was to print the body and the drum together so that it was a single piece, but it turned out that the 3D printers were having an issue with that, so we had to later separate the body and the drum and print them as 2 separate parts. We designed some holes into each of the links, actually each of the link attachment points, so that we could later, once we attach the links, we could fix them up by just inserting some thumbtacks or some screws into them, so that you don't have to rely on, let's say, super glue or anything else. And yeah, other than that, our initial design was supposed to have a Purdue Pete head model, but we were not finding that model easily on, let's say, GraphCAD or any other CAD model website. So we tried to, right now the head that we have used is basically more or less a regular human figure. And our body also, before 3D printing, we initially had more or less like solid body type, and it was going to take definitely more time for 3D printing. So later we redesigned the body to make it more hollow. But even after having it hollowed down, we actually have a body that is really heavy, and that has been affecting our balance. And so you'll notice that in the demo though, that while our mechanism works, we are actually not able to make the robot actually walk on the ground. So more or less we'll show that the robot is walking, but it's not actually going to walk on the ground though, because of balance issues.
And this is the video of it working. Again, it might be a bit too fast, but as John said, that we're going to add some resistors to adjust the speed of the motor.
And it's also running backwards in the video.
Yeah.
So we fixed that. That was easy, obviously. So, but here's our final model. So a little bit more visually, the drum, and this was the caster in the front that initially was supposed to be our third point to rest on. and there's a couple issues. The step, when he steps, one of the legs comes too close to the caster, and that's a lot of our stability issues. If this leg stayed farther back and didn't take such a big step, it wouldn't tend to fall over, but when these 2 points of contact get too close, obviously it leans one way or the other. And like you said, with the body being as heavy as it was, that was another issue we had. When we initially designed this, we thought by hollowing out completely, and these walls are only like 50 thousandths thick throughout the entire thing. Even it's hollowed out in the back to hold the battery and the motor, but even between these 2 sections, it's also hollowed out internally to try to cut weight. But it just ended up not being enough weight. When we got our hands on the body, finally, we realized how big of an issue that was really going to be. But as you can see, the motor sits in the back here and mounts between the 2 sides of the body. And then we made these push-on cam wheels down here that actually like push on to these motors that we were using in the toy car. So kind of the same way that the wheels pushed on for the toy car, our cams pushed on to the motor. From there, we have the actual leg. I can turn this a little bit just to show the assembly more. We have the leg, which pivots around the cam and attaches to a secondary linkage that goes back to the body, and that actually is providing our stepping motion. And then the 2 cams are just 180 degrees out, so you can see when this one's forward, this one's back. From there, our first idea was to actually run 2 motors in this to get our second motion, but we realized that there was really no need for it since we already had the cams down here. So we just took a linkage up to the back of the arm and created like a shoulder joint that actually allows the arm to pivot while all coming from this one rotation down at the bottom. So we can give a quick So obviously when we slow it down, it'll look more like he's actually marking.
Oh, that's good.
So we're having issues too. It's another good point. The plastic is starting to wear the more that we run it. So the plastic is actually slipping off of our retaining pins. It hasn't become too big of an issue, and a lot of it's due to the speed. But when it was first being run, it worked extremely well. As it's worn in more, the plastic has started to like actually eat away at itself, and everything's loosening up, so it tends to fall off the pins. Easily fixable, but kind of annoying.
Any questions?
Good.
Thank you.